Hello everyone. In this today's session, I will explain you about the Bresenham's line generation algorithm. This is the part of computer-aided design. There are two basic types of line generation algorithms which are getting used for study. First is DDA algorithm and the second one is Bresenham's algorithm. So in this Bresenham's algorithm, the numerical is that find the intermediate points using Bresenham's algorithm. The start point is given as a 1 1 and the end point is 5 4. So I have just listed down this given data. The P0 is 1 1 and the end point is 5 4. So if you try to plot it on the graph, so generally they are asking that between these points, if I want to generate a line, so what will be the intermediate points? So this will be the given data here, right? So the x1 is 1 here and y1 is similarly x2 is 5 sorry, and y2 is 4. So after this, my step 1 will be that calculate the slope, and you generally knows that the slope calculation is y2 minus y1 by x2 minus x1. I am replacing those values here. I am getting 0.75. M is less than 1. But generally it is not required for the calculation of Bresenham's algorithm, but just for confirmation I will request you to do this thing. Okay, so next one is calculating the decision parameter. Now in Bresenham's algorithm, the P is calculated as a decision parameter. P is very important. So there are two conditions, that what if P is less than 1 and what if P is greater than 1, right? So we'll see it. Now what I'm doing, I'm just making 3 columns x, p and y. Okay, the first step is that put the first point, which is 1 1, put here 1 and 1, keep it here. Okay, and then the first equation will be the p1 is equal to 2 delta y minus delta x. So replacing those values, this is the standard equation. Whenever you start Bresenham's algorithm, first you have to use this equation here. So the value of the 2 is here, delta y is equal to 4 minus 1. You know that what is delta y? Delta y is y2 minus y1. Delta x is equal to x2 minus x1. So 5 minus 1. So ultimately I am getting the answer 2. Now my decision parameter p is 2, which is greater than 0. Hence what I will do, I will add 1 into the x and add 1 into the y. So after adding 1 here, it will be the 2 for the next step, and this will be the 2 for the next step again for the y. So it will be the 2 and 2. Now repeating this step again, but the second step the equation changes a little bit. The decision parameter will be called as a p1 plus 2 delta y minus 2 delta x. This is the standard equation first. Okay, so p1 is equal plus 2 delta y minus 2 delta x. Placing those values, I am getting 0, or somehow you will get minus 1. Okay, so if the value is less than 0 or equal to 0, then what I have to do, if value is equal to 0 or less than 0, then you have to add 1 in x. So every time you have to add 1 in x, but you will not add 1 in y. You will put the same y as it is. So I will put it 2 is here again, and 2 plus 3, 2 plus 1 is equal to 3. Now again next decision parameter will change a little bit. If you are getting a less than 0 value here, then decision parameter equation will be the p2, which is the last decision parameter, plus 2 delta y. So replacing those values, I am getting 6, which is greater than 0. So again I have to do what I have to do, I will add plus 1 in 3, so it will be the 4, and in y plus 1 it will be the 3. So as it is, again if this is a plus positive, then I will use the again decision parameter equation, which is p3 plus 2 delta y minus 2 delta x, right? And I'll find that I got that it will be the 4. So here it is also positive, hence again I will add plus 1 in the x and plus 1 in the y. So you can notice it here that the last end point what we wanted was the 5 and 4, which I am getting here. So here my Bresenham's algorithm ends, and these are the values generally which I wanted to generate the Bresenham algorithm. So the last answer will be the P0 is equal to 1 and 1, P2 is equal to 2 and 2, P3 is equal to 3 and 2, P4 is equal to 4 and 3, and P5 is equal to 5 and 4, which I have listed here. Okay, so just keep it, remember, if positive value comes, then the equation will be P1 plus 2 delta y minus 2 delta x. If value comes negative, then P2 plus 2 delta y. Okay, these two equations are the base core part of the Bresenham. If you understand, then it will be very easy. So I suggest that you just retry this numerical again by using another values and make practice again and again. So till that, goodbye. In next session we'll take something new. Bye.